Hey, I'm Matthew Miller. I am the Fedora project leader, and this is our Fedora Council subproject report meeting. The Fedora Council is our top-level body for leadership and governance in the project, and we meet roughly once a week, and each of the 4 meetings on a rotation has kind of a different purpose. So once a month, we do a thing where we find some area of the project we'd like to learn more about, or that we know needs support, or it's just interesting, and we do a video-based call about that thing. And the other meetings are in IRC, but this one we use Jitsi, which is an awesome open source conferencing system, and it's been working out really nice for us. And then we put it onto YouTube for later archiving and sharing and watching and so on later. This week we have Jason Callaway with us, and Jason is from the Fedora Red team, which is a cybersecurity effort in the project. I think a lot of times when you think about Fedora and security, it's making sure that we get CVE fixes, bug fixes out as updates in package updates to users, which is definitely an important part of Fedora security. But the Red team is basically looking at more proactive approaches and kind of staying at the leading edge of the security curve to make Fedora safer, and I think operating systems in general through Fedora's leadership safer. Is that a good summary, Jason?
Yeah, that's a great summary.
Okay, awesome. Then I know what I'm talking about. And then I will turn it over to you for the presentation.
Awesome. Well, thanks everybody for the time to present to you today. Very excited to chat about this stuff. And I have some slides, and what I'm going to do, they're actually hosted off my Fedora people page. So if you'd like to follow along and check out any of the links, I'm dropping them in the chat window and then also in IRC.
All right, cool. The chat doesn't persist, so I will make sure I put those links somewhere later as well.
Great. Okay, so I'm going to go ahead and share my screen now. And then, Matt, if you could let me know once the slides are actually visible, because I believe there's a little bit of a delay.
Yeah, visible now.
Great. Okay. So, like we already said, this is about the Fedora Red team. This is a special interest group under the Fedora project. And we do a couple of things that I want to tell you about today that I think you're going to be interested in. But first, we're going to go over a little bit of the history of the SIG, what we originally thought it would be and kind of what it became. We're going to go over some of the projects that we have going underneath of the SIG, some of the response that we've gotten back from the InfoSec community, and ultimately why you should care and what you can do to help out. And if you have questions, please, by all means, interrupt me and jump in. I love that. I definitely hate feeling like I'm just talking to myself. So please interrupt if you have any questions. So this idea was born at DEF CON 24. If you're not familiar with that conference, I would sort of describe it as the Super Bowl of InfoSec. It's been going on now this will be the 26th year. And I was out there a few years ago with another fellow who is actually active within the Fedora project still, Josh Bressers, and we were having dinner and discussing how as Red Hat gets more into cybersecurity, and by extension the Fedora project, we expected that the number of attacks are going to go up. So the idea being that if we're going to get into this cyber thing, we better harden up a bit. And originally that was intended to be the build infrastructure. And Josh suggested that we start with the Fedora build infrastructure. So originally the idea was to truly red team to attack all of the Fedora assets and see if we could find things before the bad guys. So we made some progress on doing that, but the problem with sometimes these community efforts is that they're sort of extracurricular and you have time to work on it when you've got time. So it wasn't progressing very quickly, but things really took off at DEF CON 25, where we watched the second update to this other thing that we'll talk about here in a moment called the Cyber Independent Test Lab, or Cyber ITL, or CITL.
Jason, so for people who are watching who might not know what the Red Team terminology comes from, can you explain that?
Certainly. So there's, I believe this actually originated in sort of a military context, but the concept of blue on a map indicates friendlies, the good guys, and then red dots are typically the bad guys. So you get this red team versus blue team dichotomy, with defenders typically being blue team and attackers being red team. And this has sort of been a little bit more formalized and certainly written about to just really a lovely book. Micah Zenko's Red Team, How to Succeed by Thinking Like the Enemy. I'd highly recommend for anybody interested in this sort of thing. It talks about the concept of having organizational contrarians that are sort of inside the organization and aware of what's going on, but also not the same group that's responsible for defense. The idea being that it's very hard to accurately grade your own homework. So when you have a red team, that will be a group of friendlies who are deliberately trying to break into your stuff in order to expose any shortcomings that you might have. We sort of expanded from that idea at DEF CON 25 when we saw a really great update from the CITL folks. Sarah Zenko gave that talk, and we'll talk about that here in a moment. But to put that in context, I'd like to talk first about the projects and the tooling that we're trying to create, because they're all very closely intertwined. So we have something called the Enterprise Linux Exploit Mapper, or ELM. Now, this is a tool that was written by Ken Evanson, who's another one of the founding members of the SIG. And this will let you map local vulnerabilities on a system by CVE ID to known exploit code out in the wild. We'll talk about that more in a second. The Cyber Test Lab is our effort to quantify risk on a per binary basis. We've got Red Container, which is an effort to containerize a bunch of offensive and defensive tooling. We also have a couple different Ansible roles that help to make deliberately vulnerable systems, like the Cyber Range target role. And then we've got a compliant role that will apply security regulatory compliance stuff. And then we have plans to sort of work on that and try and drive that and make it better. So let's dig into each one of those a little bit. So ELM, as I mentioned, lets you map from local vulnerabilities to known exploit code out in the wild. So how many times when you've been looking at CVEs online, you read about it and it says that this particular vulnerability could be theoretically used to execute arbitrary code? You know, and that sort of language is important. That tends to indicate that at least when the CVE was written, that there's no proof of concept for the exploit. It's just something that we believe could be a problem, but we haven't actually seen anybody be able to leverage it yet.
We don't know how exactly it's a problem. We just know that this kind of thing looks bad.
Right, exactly, yeah. Now, in other cases, we absolutely know that it is a problem, and we have proof of concept that demonstrates that that happens. So there's a number of different data sources that serve up this sort of thing, one of which is just simply called ExploitDB. So the exploit database is hosted by the same folks who curate Kali Linux, who run the offensive security certification programs. Really great group of people. And using that data set, it includes mappings to CVE IDs. So while we were at DEF CON 25, after having watched Sarah's updated talk on the CITL, Ken and I were chatting about how we could probably make a tool that would make it really easy to tell if a local vulnerability, using stuff like the Yum security plugin and the various security data APIs that are available for Red Hat and you know, in the future for Fedora. So it would be pretty easy to make this tool. And Ken, being the wild and crazy guy that he is, he sort of nodded and said, yeah, good idea. And decided to turn in for the night, and shows up the next day with an implemented proof of concept of the tool. So it's a really great, it's a lot of fun. We have a YouTube video here if you want to follow this link to watch it, actually in process.
So and it actually pulls down the exploits and actually tries them. Is that what's the idea?
So it will stage them. So sometimes setting up a system that's exploitable takes a little bit of effort to get going. And one of the components of this ELM project is the curation of these exploits. and we're scoring them in terms of efficacy and ease of use, et cetera. And we're using a mechanism called STRIDE that was actually designed by Microsoft, and that each letter in there is representative of a different class of exploit. And in the Microsoft model, you'd indicate using just lowercase or capital for each letter as to whether or not that class was present in the exploit. We're making it a little bit more granular in each column being 0 to 9. So the idea being you could have like a tampering score of 8, but a denial of service attack of like 2, indicating that this will typically let you pop a reverse shell. But we found that, like in our testing, say like 20% of the time, it crashed the remote service. And that ends up being really useful data to know, particularly from like a penetration testing point of view, that if that D value is higher, you want to sort of reserve that as sort of a last step, because you know that you won't be able to leverage that again if you crash that daemon on the far side.
This sounds interesting. As a sysadmin, I've used scanning tools before that are supposed to tell you if your system is vulnerable to exploits, and they're mostly false positives because it doesn't know that Fedora patched that in an RPM without increasing to the version number, or Red Hat did the same thing. So this actually looks at the vulnerability rather than doing one of these like compare RPMs to CVEs sort of things.
That's right. So the first thing that it'll do is exactly what you said: compare RPMs to CVEs. Using the Yum security plugin, it can get CVE info based on the versions of RPMs that are installed. Now, once we have the CVEs in hand, we're able to map those to things from the exploit DB data set. And then we,
sorry,
like we're saying,
one thing there. So, but what you're saying though is that it's actually looking, so the CVE may be listed as fixed in the RPM. So you're not actually looking at, is this TMUX version 2.6? You're looking at, this is RPM of TMUX 2.6. So therefore, it has a CVE list of these patches.
Yeah. So have you ever used the security plugin to Yum before, where you can get back a list of CVEs that are present? Like those are representative of the CVEs that are sort of open and like dangerous on the system, the vulnerabilities that currently exist. So then once you actually Yum or DNF update, those will disappear, and it's we're using that data to do that mapping. So it's not like you have to downrev. Like when you run LM, that's actually representative of what's vulnerable, and then what you can find in a data set like ExploitDB. And this is maybe a good time to mention that we hope to add additional data sets in the future. ExploitDB was just super convenient. It's actually on the back end, it's a Git repo that we clone down and are able to index. So there are others, and we would like to be mature enough to have sort of a threat intelligence approach to this, where we might be, say, like monitoring IRC or the various chans for really fresh stuff, but we're just not there yet.
So it sounds like this partly depends on Fedora having pending fixes for things. So it will be blind to things where there's a CVE, but maybe Fedora missed it entirely, or we just don't have a fix ready yet. Is that
right? So the metadata is very important, and we called this ELM, the Enterprise Linux Exploit Mapper, because that metadata was readily available for RHEL, particularly like using that security data API. So Red Hat offers a really great RESTful API that you can use to pull down all sorts of SCAP data, including CVEs and oval mappings and that sort of thing. CentOS is pretty close to that. That it's rare that you get a CVE that's on RHEL and not on CentOS, or vice versa. Fedora is a little bit more difficult, and we actually hope to create our own Fedora security data API at some point. And Ken actually has a sort of beta of that already up and running, but it's not quite ready for prime time yet.
Okay, cool.
So this is really, as of today, Elm really works best on RHEL and CentOS. The support that you're going to find for Fedora is not as good today, specifically because we're missing that metadata.
Yeah, okay. Metadata is definitely important, and that's one of the things as we're a lot of the times we miss the metadata when we get a package fixed in Rawhide, because then it doesn't go through Bodhi, and then it doesn't get the metadata attached to it. So we're looking at making all of the rawhide packages go through Bodhi, which will help with metadata there.
Yeah.
There's other things we could do too. This is a reason for that I hadn't even thought of. My reasons were mostly sort of metrics related rather than actual practical real world. So this is good.
Yeah, I mean, just to go back to Ellen for one more moment, the risk of kind of beating this horse a little bit more. This is useful in two different contexts. I mean, this is useful for both blue and red team members, because if you're a system administrator and you're defending, this really helps you get downtime from management when you need to be able to patch. You know, one of the most surprising things to me to learn after coming to Red Hat was how, you know, lots of customers, for various good reasons, don't patch regularly, you know. So, like, imagine, just for the sake of the argument here, some, you know, relatively small e-commerce website that hasn't quite figured out how to cloud yet, and for them, downtime means loss of revenue. So that means the leadership there has to decide the risk of intrusion, the monetary risk of intrusion versus the cost of that downtime to update. So having this sort of data in hand as a system administrator to be able to say, hey guys, like any Yahoo out there can come own our stuff using these 3 exploits that have known code out in the wild, that sort of adds a super criticality to the issue that might help the defenders be able to get that downtime to patch. And then from like a legitimate red team perspective, if you're a penetration tester, this really helps you enumerate the vulnerabilities that you might be able to leverage during the course of a pen test. And also just learning. Like this is a great place for people who want to learn more about offensive security to be able to fire this stuff up and look at vulnerabilities that are mapped. I'll send out after this a link to our Trello board where we're tracking the vulnerabilities that we're trying to curate and test and, you know, verify whether or not they work on our platforms. So it's a great way for people to learn in addition to offensive and defensive roles. Any other questions on Ellen before we move on? Cool. So the Cyber Test Lab is something that I've been working on that I'm pretty passionate about this. I think that there's really important work to be done here, and we owe everything to the Cyber ITL for sort of showing us the way here. So Sarah Zatko and Mudge started this project, and theirs is much more broad and much more mature than ours. So the idea here is that we want to be able to do quantitative analysis of risk on a per binary basis. And when we say quantitative analysis of risk, what we mean is how hard would it be for a security researcher to find a new 0-day in this given vulnerability? Not like, is there a 0-day in it? And certainly, like, that's where we'd like to be in the future, to be able to say with certainty or with you know, statistical certainty that a 0-day exists there, and perhaps someday even like what class of 0-day it is. But right now, just to basically be able to create a histogram that describes really well-developed and well-compiled binaries versus others that show signs of risk.
So does this is this related to the AnnoBin stuff at all we have in Fedora, the new Fedora release?
I'm not familiar with AnnoBin. Can you describe that?
Yeah, I can send you a link to it. It's basically a thing to watermark build options and some other things into ELF binaries so they can be more easily seen how they're built.
That'll be great, actually. So what we're using today to do the static analysis and generate this data, and I'll show you an example of what that looks like, is a tool that was written by an engineer named Keys Cook. When he wrote it, he worked for Canonical. I believe he since moved on to Google. And the tool is called Hardening Check, and it's available in basically all Linux distros now. If you look at it, it's actually a Perl script. And this uses a number of different techniques to infer whether or not things like ASLR or stack protections or RELRO have been compiled into that binary. So these are typically things that would be arguments on your GCC call to compile that source code. So this ends up becoming a pretty important thing to look at, because when you think about like static analysis of source code, you know, that will find some vulnerabilities certainly, but its awareness ends, you know, at the code. So if something's then compiled and they don't include PIE, or position independent execution, which is ASLR in GCC lingo, then you don't have that. And there's no way to tell from a source code analysis perspective of whether or not that's there. So having like that watermarking would be a very useful feature for us, and I'd love to read more about that.
Yeah, I put some information in the chat. I can email it to you as well. Like this seems exact, like somebody's working on exactly the other side of what you need. So that seems perfect.
Yeah. That'd be great. We'll definitely include that as something to look at. We're also looking at things like cyclomatic complexity, which if you've ever taken any algorithms classes, you might remember this kind of esoteric metric, which is basically a measure of how many moving parts exist in the binary. And the idea being that the more complex it is, the more easy it will be to subvert. There's sort of an analog here to physical machines, where a very simple machine tends to be very robust and long-lasting, and then really, really complex machines have more opportunity to break. So these are the things that we look at. Here's sort of an example of the output that gets generated by CTL. This was looking at an Amiga file reader, which is still out there in Fedora. Can't say I've ever actually used it, but you can look through here and see like the hardening check report there, where Relrose enabled, but it's a normal executable. So because it does not use position independent execution, it will land in memory the same way every time, which makes it a lot easier to craft a buffer overflow exploit against that. You can also see the complexity values up there, which are very low in this case. So that's what you do want to see. So using all those different metrics, we score these things, and the way that this scoring works is probably wrong, and B, worth another Fedora meeting just to talk about and come to consensus on. But given what exists today, and I can point everybody in the code to where that scoring lives, this is an example of sort of the output that we'll get. I haven't quite pushed this version, by the way. I'm actually very behind. The work that I did to integrate Elasticsearch and Kibana, in all honesty, I did over Christmas break, and it exists in like 3 or 4 other places, and I need to clean it up and push it out. So this will be happening soon, but this is an example of what that looks like. And on the right-hand side here, you can see these histograms. For red is RHEL 7, purple is CentOS 7, and the blue color is Fedora 27.
So is this a graph of across the available packages or across a certain install?
This is across, so for Fedora 27, it's for whatever is available in the Yum repos with a base install. Same thing for CentOS 27, and I believe that includes EPEL. For RHEL 7, I did the base media extras and optional.
Okay.
So that itself is problematic because we've got a different set of binaries. So for a really good side-by-side comparison, we should be looking at the same, if not the same like version, at least the same code base. So that's one reason why we haven't been really like vocal about any of the output yet of this tool, because we don't trust it. Like we have no idea if we're correct with the approach that we're using. So I'll talk in a moment about how we get to like confidence in these numbers.
Yeah, things that look pretty but might not be correct are like the most dangerous.
Right. Right. So if you were just to go off of what you see in this graph, one might conclude, because basically the heavier everything's skewed to the right is good, the more stuff you see over on the left is bad. And those things on the right would be very hardened binaries, and on the left, like those are the low-hanging fruit. Whereas a security researcher, that's where I'd want to spend my time fuzzing to try to find a new vulnerability, a new zero-day. So maybe if we have time, we should take a moment just to sort of talk about fuzzing, if everybody's not familiar with that. So there are a couple of different ways to find a new vulnerability. Sometimes you might have like such command of the code base that you just know intuitively, like this is not done right. I'll bet that I could do this sneaky thing to break this code. So sometimes somebody's just really, really badass and knows it well enough that they're able to do it sort of by feel. Other times, people will research the code specifically looking for common like anti-patterns and how to do things, and then try various approaches to break that. And then another approach, which can take the form of complete black box testing, or sort of more informed testing, where you insert tooling into a binary. You use this approach called fuzzing, where you send deliberately malformed input to a program and then try to get it to crash and go back and analyze what happened in the crash to see if it's something that you might be able to leverage. So this kind of relates to what you're seeing in the pie graphs here. So the leftmost column is position independent execution, or whether or not ASLR is enabled. So ASLR is address space layout randomization, and it makes buffer overflow exploits a lot more difficult to actually be able to leverage, because you don't have your code landing in the same place in memory every time. Same thing for stack protection. When you have stack protection enabled, if you land in a place that's not designed to be executed, even if you are able to get most of the way down the road to a buffer overflow, you might not actually be able to execute what you've put into that register to get it to jump to where your arbitrary code lives. So these are two pretty important metrics, and the idea here would be that you would fuzz things that land on that left-hand side. For example, on the rel histogram, you can see there's something there in the -120 range. That one would be very interesting, and you'd hope that from an attacker's perspective, you would hope that that guy also does not have PIE enabled and does not have stack protection enabled, and that one's a really interesting one to try to fuzz.
Can you tell us what one that one is?
It's not particularly interesting, if I recall. I think that it's you know what? I'll go dig that up and send it to you so that you can include it in the notes. All of this stuff is on GitHub, so anybody is able to, including all of the results of the scans. So if you want to look through this data yourself and maybe become a bug hunter, or and start looking for these things, you could absolutely use this output to do that. You wouldn't even have to run it yourself. And that's kind of the point. We want to make things much more clear about how we can improve our build practices to make it more difficult for people to find these new vulnerabilities. So just last thing here before we move on, the end state for this is to be able to do that fuzzing in as much of an automated way as possible. I don't think that it's possible to fully automate, but we can make it faster. And then being able to say, 90% of the time we were right about, like, that, say, that -120 guy there. Being able to say, like, yes, we thought that there was a vulnerability there based on the statistics. That one looked really promising, and it turns out that there was. So, like, at that point, we'll actually be able to trust the output of this tool, and then, like, really start talking about it and taking action against it. Like, right now, it's still a science project, and we're not at all mature enough to really start, taking any action. Like, because you asked, like, what is that guy that lives there at -120? So, like, let's say that we come up with a package name. So, like, how long then until the package maintainer gets a nasty email that says, hey, tighten up your stuff, man, like, this is not good.
We prefer to do it with a nice email first.
Yeah, right, sure. We don't know for sure yet that it's even an issue, so we need more confidence in the data before we start going there. But we know that, like, there are some edge cases, say, where you don't want to have position independent execution enabled, but the vast majority of times, like, it doesn't break what you're trying to do. So we know that we can probably make things better by changing the way that we build things, in Koji and Copper as well. So if we could start turning on some of these compiler time flags, we'll definitely make things better.
So what about things over on the right side of the graph? Does that tend to indicate that those are I won't say secure, but state-of-the-art best practices for compiling things securely in 2018?
It indicates that for the things that we're checking, like you could get a completely clean result back from hardening check. That would be good. You could get back from we're using a reverse engineering framework called Radar to generate our function call graph, which is necessary to build cyclomatic complexity values. So you could say, like, this particular binary comes back clean on hardening check and has a very low complexity. And we believe all of those things to be good. But in terms of, like, is it secure or could you find a new 0-day in it? Like, we don't know until we've tried. So that's what I mean by, like, we need more data to actually be able to say. But conversely, I'm unaware of any situation where it would be bad to have all of these things enabled. Like, I don't think that your life is worse when you have a clean hardening check output and you've written very small binaries that do a limited number of things. Like, that's kind of generally well accepted best practice, Maybe one other, another question that I get frequently about this is, what about Java executables? What about interpreted languages? And the answer is we want to be able to do all of those things. But right now, this is just sort of community effort, sort of, like I said, the last big push that I had was over Christmas break. So it's one of those things where we work on it when we're able to. So in the long term, I would love to see more community involvement and corporate involvement in doing this sort of work to be able to check ourselves before it goes out the door. This would be a great kind of final QE check before we actually put stuff into a distro. And in order to make it really useful, we have to be able to speak more than just ELF executables. There's lots of other stuff out there, and even some ELF executables, given the techniques that we have today, are not practical to analyze. For example, Golang, because it's a statically compiled language, and it builds all of the libraries into that one executable. I've never actually been able to get it to analyze using Radar to be able to build that function call graph because it's so massive, So we need.
Yeah, that was the thing I was going to ask.
Yeah. So like there are some ELFs that in the CTL code today, we've got a timeout value where if it runs for over a couple minutes, we just say, forget it. Like, we're never going to figure this out. Move on. So it has a very long way to go.
So yeah, and the Anno bin thing I was talking about earlier is GCC feature, and I don't think that works for LLVM stuff. So that means Rust and all those fancy new hot things are kind of out of the picture. So plenty of work to do there.
Yep. So please, if you know stuff about this, we would love your help. We'd love to make it better. Red Container is another project that we're working on. This is our attempt to containerize offensive and defensive tooling. The first question that I always get here is, are you guys making a Kali Linux based on Fedora? And the answer is no. There are lots of offensive-minded distros out there already. Some of the really good ones are Kali, Blackarch, and Parrot. Lots of people use these. They're great. I don't think we do the world any benefit by making yet another one. But it would be really nice if we could take these various things that are included in these distros and just do a Docker pull and run on them to be able to use them from any Linux operating system.
Yeah, that does seem valuable, because if you go to like Stack Exchange and look at Kali Linux questions, a lot of them are people who are trying to use Kali Linux as a desktop operating system and becoming frustrated, and then people getting frustrated trying to help them, because although Kali is awesome for what it's meant for, it is not meant to be a general purpose operating system. So having something that is, this is a good desktop system, or whatever server system, and then you can also have easy access to these tools, seems like that is good for people and doesn't sort of compete with Kali's particular niche.
Absolutely. And I would see this as even, helping these other offensive distros, because they too would be able to leverage these containerized versions if everybody's using the same thing. then we all benefit because we can be sure they're configured correctly and optimally and that sort of thing. So the idea would be, typically when you run Metasploit framework, you need a PostgreSQL backend. That works great when you've got them inside containers. And then if you want to run them on Kali or regular old Debian or say RHEL, for example, no problem. So that's what we're doing in Red Container. We've had really great contributions from the community on this one. This is also another easy one to get involved with. It's not quite as hard as like the brain-bending stuff around binary hardening and the hardcore like algorithms work involved there. Just containerizing the tooling that already exists in these other distros, like that's kind of an easier place to get your feet wet. So this is another place if you want to jump in and help where the barriers to entry are pretty low. Is
this going from source to RPM to containers, or is this going source to container basically?
So great question. All of the containers we have today, and I should say that's not many. We don't have many Docker files yet. We're still building this out. But all of them that we have today are using Fedora as our base image. Theoretically, we may encounter some tool that simply does not work well on a Fedora-based container, and we might need to use Debian as the base image. We haven't encountered that yet, but once we do, that's going to create really interesting ripple effects of, like, if we ever want to include these in a distro, what does that mean to us as the Fedora project? Are we going to start shipping other distros base images in order to work with this? So there's actually, it's a bit of an iceberg here because we're going
to say the least,
kind of encounter problem spaces that we haven't had to deal with yet. But today, everything that's in there works fine with Fedora as the base image. And some of them are installed for RPMs. Others, like if you look at the Docker files, we're getting the source code. And
that's beautiful, man. Beautiful.
Yeah, it's super secure. It's all the things that you tell somebody not to do from a security perspective, we're doing for security work. So we're not practicing at all, what we preach. But, crawl, walk, run. First step is to just make it work, and then make it right, and then make it fast.
So, sorry, I had a quick question. You may have said this already, but what is MSF?
I'm sorry. Metasploit framework is.
Oh, okay.
Yeah.
I know about it.
Okay, great.
You may want to explain it anyway for people on the call, but
sure. So
I didn't get the acronym.
Metasploit's a really useful. The best way to describe it is a framework that makes it easier to run these various offensive tools. So, in fact, it integrates really well with ExploitDB. Most of the things that get posted to ExploitDB you'll sometimes see like C proof of concept code, and then somebody will come along and turn it into a Metasploit module, which then gets sort of rolled into that framework and makes it very easy for people to execute. And it also does great things around like handling your session persistence. There are various tools like Meterpreter for one that makes it easy to like manage the reverse shells that you get. So I'd encourage anybody who's interested in offensive stuff to go learn about Metasploit. I sometimes hear people criticize Metasploit as sort of like being a crutch, and I don't think that's at all true. I know plenty of professional pen testers who use it, and actually in addition to that, the sort of premium version that's published by the company that maintains that, called Rapid7. I think it's called Metasploit Pro. Just because you've got a convenient tool doesn't like reduce the coolness factor, I guess, of what it is that you're working on. So I find only people that are like peripherally involved with this tend to hate on MSF. So I'm a fan. Okay, so we've talked about stuff like Elm and vulnerabilities and testing them. Particularly like with Red Container based stuff. How do you actually make a system that's vulnerable? We all know how to patch systems, but down revving is kind of a pain in the butt because you've got to figure out what versions of RPMs go with those. So Ken Evanson wrote a really elegant role that will just take a list of arguments of CVEs that you want to make vulnerable on a system, and then downrev the RPMs to the versions that are vulnerable to those CVEs. Now, this is really, really useful, particularly in the context of what we call cyber ranges. So the term cyber range is actually a thing. You'll find it most frequently like in DoD procurement language. And this is an environment where cyber warriors or security researchers or just anybody interested is able to practice these techniques. So the idea is that you'll have a virtualized environment, maybe a cloud-based environment, where you can spin up deliberately vulnerable systems that create some sort of scenario, and then you've got an attack platform, maybe a Callaway VM, with the exploits preloaded. To be able to practice attacking and leveraging those different exploits. But you can't do that, often because, like, say you load a base version of RHEL, like RHEL 7.0, and then it might be much later, like RHEL 7.3, that a particular vulnerability was entered into that, that code base that then gets patched later on. So it's hard to rev up. You can't just yum update, you have to be able to rev down. So this does a pretty good job. The end state that we really need to get to is what I call point-in-time downgrades that would be truly representative of the vulnerability. Because in the case of, say, shell shock, we're able to downrev Bash or even, Apache to relevant versions. But what about everything else on the system? They're all at a much later patch date. So it would be great to be able to say, I want to downrev to, March 1st, 2018, if I knew that a particular vulnerability was present at that time. That's a little bit more difficult. And it's not impossible. Like in this case, hard, I mean hard like when you put a bunch of A's into it, like it's hard, like more so than I was able to do while I was, like goofing off sitting on the couch one night. So that's something that we want to get it to. We're just not quite there yet. But this is a pretty useful role. So compliance. I'm betting that lots of people online or that are watching this video later have at some point had to deal with security compliance issues. The term that frequently gets thrown around is FISMA. And I actually have a separate talk that I do just on FISMA compliance. It's a pretty big problem for a lot of folks.
Can you expand FISMA for the non-sysadmins watching?
Sure. So we learned the hard way what happens when you ask legislators for help with InfoSec. You ended up with something like FISMA. So that came about with the E-Government Act of 2002. That was written into law. It was amended later, and FISMA is the Federal Information System Management Act, I think. So this is actually in United States code. I want to say something like, I'm not going to cite the version just because I know I'll get it wrong, but it's the law. You have to comply with these things if you're working in the context of federal DoD civilian governments. State and local stuff has to do it. And when you have to be compliant with this, you worry about things you may have heard, like NIST 853 is a standard that people throw around. That's like all of the generic security controls, meaning like the particular things that you need to implement to ideally to make something more secure. And then you may have also heard of something called the STIG that's published by DISA. That's the Security Technical Implementation Guide, which is supposed to be all of the discrete instructions on what to modify to be compliant with those individual security controls. And I think anybody that's done this agrees that there's an awful lot of cruft in this process, stuff that you have to do, but we don't actually believe makes us more secure. And I haven't seen a lot of work done around a holistic approach of take a given security control, does that actually make us more secure at the end of the day? And now that we've got tooling like Elm and like the cyber range target role, we're able to more effectively test particular vulnerabilities that are out there. So the goal of this compliance project is to really first get a very good picture of all of the controls that need to be applied and what goes into that whole risk management framework that you have to follow, like NIST RMF or DoD RMF, if you're doing this from a military point of view. And then be able to start down selecting those to be able to say truly whether or not they're making things better. Because if they are, great, then it's just a question of optimization. But if they're not, we need to be active, from not just a legislation point of view, but also like with the various standards bodies like NIST and like DISA, to make them useful. Either make it useful or make it go away, because it's compulsory. So we have to make it better, or get rid of it. So the goal then of this compliance project is to use all of this tooling that we're creating to actually start attacking unconfigured systems and compliant systems, so that then we can say, like, for this type of vulnerability or for this class of exploit, we find that these controls actually do make it harder to leverage. And then we can say all these other things simply do not apply. And we could even trace those back to something like the STRIDE framework to indicate, what class of exploit or vulnerability is, affected by various controls. And then from that standpoint, based on like impact level and the mission of the system, be much more selective about which ones we have to apply and monitor. And
so your goal is better legislation based on actual data in the end run?
Yeah, that is a great utopian endpoint.
Yeah, it seems ambitious. I mean,
yeah, that's where we'd love to be. But we're not even ready to crawl here yet. First thing we need to be able to do is apply the security controls in a reliable way. There are some projects that already do this stuff. There's Ansible hardening under the OpenStack project that is really great. The OpenSCAP project has some ability to remediate things. But because we plan on changing this stuff a lot, we kind of wanted our own little universe to work in, where we can start from what is in the STIG, start from what addresses these 853 controls, and then start getting to a better point of where we think it actually needs to go. So that's the compliant Ansible role, applies those roles, and then the compliance project, which in hindsight we realized might be a bit of a name collision, is sort of the more meta aspect of dealing with risk management frameworks and bodies of evidence and documentation and that sort of thing. Any questions on that? Great.
Hey,
so,
Nick, are you still on the line? You're a large installation sysadmin. You got any thoughts? Maybe
chat,
not.
Perhaps. Yeah, I'm not able to see the chat window.
Right.
So if he's able to get those to us, either in I or see your chat later, that's fine too. So there's been some community response to. Oh,
I might be here.
Go ahead.
Can you hear me?
We sure can.
Yeah.
Oh, okay. I thought I got it to work with my microphone on my little earbuds, but apparently that doesn't work. So I put my other headset, my phone headset, back on.
All right.
I've been listening to it.
Anything here sound useful for what you do in your day job?
I think it could. Right now, we're just pretty much focused on, we have weekly Nessus runs, and then we go try to fix what it comes up with. But I like the idea of the Dockerized or containerized system for running Metasploit and things like that.
Great. Okay, so moving on to community response. The most important thing to me personally, since I was doing so much work on the CTL stuff, was hearing back from the creators of the real cyber ITL that they were positive on the work that we were doing. So we got some conversations there going on Twitter, where
it's like David Bowie's like, "Hey, I like your song, man."
Right, exactly. Yeah, the at the risk of sounding immature here, there's a bit of hero worship going on for me here. So I've always been really inspired by Mudge and what he's done for InfoSec, and he and his wife Sarah are just really huge in the community, and having their support was just fantastic, a real boon there. We also got talked about in an article, which I've got on the next page, but just hearing things like this, like the fact that the work that we're doing with creating our own test lab to try and proactively make our distro more secure before it goes out the door. The fact that somebody like Mudge, like Peter Zatko, head of security at Stripe, would then consider using our distro as a result of that work is itself a big defense of the project. So we're really excited about working more on that. I mentioned the article. So CSO Online discussed our cyber test lab work. There's a link to that there. You need free registration to read it, but they haven't annoyed me yet, so I don't think that's so bad. Other places have written about it, like the Phoronix test suite. I'm a big fan of Phoronix. I use that frequently in my day job. Whenever there's a question about performance, like this is the tool that I go to because it's really easy to do performance testing badly. So you definitely want to take advantage of work that others have already done to make those test harnesses. So the founder of Phoronix wrote about it as well. There was some nice discussion of that in the comments. On my blog, I got lots of interesting tracebacks to various places where people were talking about this sort of thing. Strangely, a number of them in Germany. So I guess it's a popular thing in Germany. Speaking of which, the sort of European analog to DEF CON is the Chaos Computer Congress. That's been going for longer than DEF CON, in fact. I should maybe say that DEF CON is the analog to C3. So their 34th one had a great talk by the new director of the CITL, and he gave us a nice shout out there. So that was also really heartwarming to hear that people are paying attention and care about the work that we're doing. Speaking of caring about the work, that's sort of where we are now and why the rest of the Fedora project should care about this. I see this as opportunity. This is an opportunity not just to make Fedora, the Linux distribution, more secure, but to really make all Linuxes more secure, and have an impact on a global scale of fixing InfoSec. It's in terms of making things better from a cybersecurity perspective. I think it would be possible to write a paper proving that this is NP complete in terms of complexity. This is not something that it's just if we do A, B, and C, then that will yield X, Y, and Z things that are so much better, and we should all do that. Like, lots of smart people have been working on this problem for a long time, and there are no easy answers. So this is our small way of contributing to that larger effort to make things better, and it's an opportunity to show some thought leadership from a Fedora perspective in terms of doing that quantitative analysis of binary risk, being able to apply security controls, and then getting a feedback loop going back to DISA, back to NIST, back to NSA-IAD, and ultimately legislators to try and fix compliance and make that better for everybody. So in addition to all of these things, which are just good for the Fedora project, it's simply the right thing to do. More and more conflict will be moving into the cyber domain of warfare because it's a cheaper place to do it. Everybody can play. You don't need to be able to make ICBMs to fight in the cyber domain. So we'll see more and more stuff happening there. And
you need to be able to make teenagers, and there you go.
That's right. That's right. So we need to all do our part here to make things better. So it's the right thing to do. So if you're wondering how can you help, there are two ways to do it. One is just talk about it, tell people about it, amplify the story, so that we can get more people using it, get more bugs opened on GitHub, more issues open, so that we can fix problems, make the documentation easier to read, and ultimately we need pull requests. We need more help from the community to actually implement these things. And those are my asks. So does anybody have any questions about any of the projects that we have going, or our goals, or our history, or anything else that we could talk about here in this context?
I said a lot of things, so I will be quiet and let other people talk if they'd like to. If you have a question, turn on your video and start talking.
I'm checking IRC here and chat just to be sure. So that's fine. I totally understand that this is the middle of the day for many people here, and that's... Oh, great. I see that we do have a question, but we can't get the mic to work, so please...
Can you hear me?
Oh, I can hear you now. Yes.
Sweet. You might even have video. I have no idea. You didn't actually provide kind of a pointer, at least I didn't catch it, to where kind of the Docker container work is going on. Like if I wanted to go Docker pull that now, or go, kind of find out where that stuff is, where would I find it?
Sure. So everything can be accessed on our GitHub. So in fact, if you just Google Fedora Red Team, it'll come back in the first page of results. But that particular, and all of these links are in the slides that I put in IRC and on the chat window here, which I believe Matt will put in the YouTube page for anybody watching this out of sync.
Yep.
But I'll just drop the relevant link there into the chat window. So github.com/Fedora Red Team, all one word, and then red-container is that bit of work that's going on there.
Cool.
Okay, cool.
So in terms of like Fedora publicity and PR, we tend to do that on Fedora release cycles, and we've got a release coming up. Are there things that would be useful for me to talk to the press about as part of the Fedora 28 release push coming up?
So possibly stuff like the watermarking that you mentioned, and how that will be integrated into the work we're doing with Cyber Test Lab. I think that we could work to get LM ready to ship with Fedora. We haven't really even given that any thought yet, and I'm definitely shooting from the hip here. But of all the projects that we have, that's certainly the closest to being ready to go out the door with a distro. So that's maybe another thing that might be a good possibility. In fact, maybe even just having the feedback loop now of what could we include, in the new release as features from the Red Team is something that we haven't considered but can start tracking.
Okay. Yeah, I'll talk to you a little bit more offline about that. Also, are there any upcoming conferences that are kind of related to this that you'd like to be at, or to have other Fedora people go to talk to about this?
Absolutely. So that is a fantastic question. So the easiest one for most people to get to will be a B-Sides conference. The Fedora Red Team has actually covered a number of these different conferences before. So if you go to bsidesecurity.org, I think I'm just going to check while I'm talking. That is securitybsides.com is the correct URL. So what's really great about B-Sides, it was actually born out of DEF CON and Black Hat. So the two biggest conferences that go on in the US are DEF CON, which is very community oriented. It's all cache only. Amusingly, their history, in fact, really all of the history of InfoSec is sort of one of misunderstanding with law enforcement. So there's sort of a long history of the feds not really getting that all InfoSec people are not also computer criminals. So that certainly everybody understands this now. But back in the day, imagine 25 years ago, there were lots of instances where simply by attending DEF CON, you were sort of put on a watch list of possible computer crime. So everything at DEF CON is cache only, as sort of a nod to this part of their history, that they can't simply audit the payment card processor to see who's been around doing stuff, which ultimately is kind of silly in the age of video surveillance that we live in. Like there's and also, unless you're going to drive there and keep your license plate from getting on any video cameras in the process, like getting to DEF CON in a completely black hat fashion would be a good trick. Speaking of black hat, that's sort of the corporate version, so it's much more expensive. But anybody that's working in the business of InfoSec tends to attend that one. But because these are so big and they get so many different submissions for talk proposals, they have to turn away the vast majority of them, and many of them are quite good. So these two guys, Chris Nickerson and Jack Daniels, his name is actually Jack Daniels, lovely guy, had this idea of renting a house and giving people a place to present their really cool talks. And it was super popular, and they quickly sort of got into fire code violations in terms of number of people in their rented house. So they did it again following years, and that's sort of where this B-sides thing came from. It's the all those other good talks. So it over time it got popular, and people were saying, why isn't there a B-sides in my area? And Jack's answer would be, there is, you just started it. So they open sourced the conference model, so anybody can start one of these, and they are now in over 90 different locations worldwide. They've had over 300 events, and for anybody watching or listening, there's probably a B-sides near you, so I would encourage you to support them and go check it out. Other important ones, obviously, are Black Hat and DEF CON, and every other year there's a conference in New York called HOPE. It stands for Hackers on Planet Earth, and that's organized by the 2600 folks. I would highly encourage you to go to that one. Really great talks every year.
I would really love an excuse for Red Hat to send me to HOPE. That would be awesome.
I actually have an extra ticket, so I think it has your name on it.
Awesome.
Actually, so speaking of which, the DevOps Days does a similar thing, and I don't know if they were the first, but of kind of that open source, kind of franchising conference model, and it works really well. So, very much +1 to that. One thing I was going to ask though is, one of the things we've been kind of looking around for is kind of better ways to promote Fedora in a kind of non-traditional, straight-up operating system manner. I just kind of briefly looked at the B-sides page. I mean, they do take sponsorships. Is that something we can have a Fedora Red Team booth at one of these or more of these, and kind of talking about, using the? I probably would focus on using the containers, even though we're Fedora. I think that might be kind of cool.
I would love to do that, and in fact have done that in the past. Fedora Red Team has already been at B-sides DC, B-sides Delaware. We tried to sponsor the Baltimore one, and unfortunately that didn't work out just due to funding. But that was all happening from like a Red Hat North America public sector marketing budget perspective. So I think if this is me +1ing the idea of from a Fedora budget perspective, going specifically for Fedora to these events, I would 100% support that, and would have airline points will travel. I'll be happy to assist people with that. There's lots of stuff that we need to be able to get there. Like, for example, none of the corporate marketers that I worked with were aware of or could locate like simple things like a Fedora tablecloth, for when you're covering these things. So
yeah,
we need some like basic conference gear to be able to do that. But even I'm all like, I can't give that enough +1. Let's do it.
We have a very standard, very nice model with money involved that you can easily apply for. And we just try to simplify it as well.
Langdon, Nick's trying to talk.
I can get with you about how to do that.
That would be awesome.
Yeah,
I actually have a flyer that I give out at these for the Fedora Red Team, and I'll drop that into the chat window.
Cool. And I like the idea of local events like the B-sides you're talking about, because that lets us have, I think our ideal model is lots of people at events near them rather than a lot of, a few people traveling around the world, because, we are a global project and it just doesn't scale to, get you to Japan or whatever all the time.
Yeah. Not that I'm saying no to that.
Exactly.
Excellent. Okay, I dropped a link to the data sheet. This is, I've actually got a stack of them next to my system here. this is what I've been sort of printing at a local Kinko's and bringing with me to events to give out. And what's interesting is there's a lot of interest and demand for this stuff. Like when we first started going and saying Fedora, going to these events, saying Fedora and talking about it, like there was a lot of interest and demand. And I frequently give away every single flyer that I print for this because I think there's hunger for the RPM ecosystem to be in the InfoSec domain. And we're maybe a little bit behind there, because we focus so much on reactive defense from an enterprise perspective. Now that we're doing more active defense and offense, we're a little bit behind and kind of newcomers here. So we've got nowhere to go but up.
All right, cool. And we're a little over the hour here, so I think we should probably wrap up. Thank you very much, Jason. This was awesome and informative. I will get this video up and shared as soon as I can and talk to you more about the future of all this.
Awesome. Thank you so much for your time, everybody.
Thanks, everyone. Bye.